All right, so now we're moving on to reference angles. So the first thing you need to know, let's do it in red and kind of circle this. This is huge, but our reference angle is always an acute angle. It's also a positive angle. So it'll be a positive number, but it's an acute angle. So it's less than our 90 degrees. And it's going to be formed by the terminal side, wherever your angle ends. So here's my terminal side, and the x-axis. So it's either going to be this x-axis over here, since it's in quadrant 2, that x-axis right below it, or if it were in quadrant 1 or 4, you're going to use the positive x-axis. So this is your reference angle right here. So here's your theta, there's your reference theta right there. So when you're doing these problems, they're going to ask you to, first of all, sketch this angle. So 225 degrees. I think that this is even more important on the reference angles to label your coordinates here. So this is my 0 degree angle. It's a positive, so we're going to go counterclockwise. There's 90 degrees, plus 90 is 270 degrees, plus 90. Oh, I already messed up. Goodness. 90 plus 90 is 180 degrees. 180 plus 90 is 270 degrees. And we're up here at 360 degrees. Okay, so this 225, it's bigger than 180, but it's not quite to 270. In fact, it's probably close to in the middle of there. So we're going to draw that angle that would normally go from our positive x-axis and go all around to our terminal side. Okay, now remember our reference angle goes from the terminal side. Let's do this a different color. So here's my terminal side to the x-axis. So here's my x-axis right here. So this is the angle that I want. So basically what you're doing, I like to kind of label this angle. This was my 225 degree angle. So you're just trying to find the distance or difference between this angle and the x-axis angle. So these two angles, that's all you have to do. And it's positive. It's a positive number. So if you get a negative, just make it positive. So we're just going to take that 225 degree angle and subtract 180 degrees. And that gives us a 25 plus 20 is a 45 degree angle. So that is our answer. This angle here is 45 degrees. That's our reference angle. Okay. All right, let's try this one. This is a negative angle. So when I label all my axes here, I'm going to start still at 0, but I'm going to go clockwise here. So this is negative 90 degrees, then negative 180 degrees, then negative 270 degrees, and then I'm going to write negative 360 degrees as well right here. That's on that x-axis. So negative 310, more than 270, not to 360. Again, somewhere kind of in the middle of that. So when we draw our angle, it's clockwise and it's going to wrap around to that terminal side. Okay, so our reference angle, again, it goes from our terminal side. Here's my terminal side to the x-axis. Here's my x-axis. So they're wanting that angle right there. So again, I always find it helpful to kind of to note this terminal side was at negative 310 degrees. We're just trying to find the difference between this angle and my negative 360. So you just subtract them, negative 310, subtract negative 360. Basically from 10 to 60, it is 50 degrees. So that is going to be your reference angle right there. Just find the difference between the terminal side and your x-axis. Okay. This is a fun one. They did this in radians. Again, a lot of my students keep wanting just to convert it and then do it in degrees, and that's fine. But I'm going to do it in radians because I do want you to learn that. When we count in radians, remember, this is still 0 radians. And then all the way around the circle, if I want my 360 degrees, it's 2 pi. So I always get those numbers, and then I kind of just say, okay, this is halfway. So half of 2 pi is 1 pi. And then I could even say, okay, so this is 2 pi thirds. I'm going to say this is 3 pi thirds. Everybody okay with that? So 3 divided by 3 is just 1 pi. I just wrote it in 3 over 3 so that we can kind of see that this is 2/3 of the way from 0 to, so if I broke this into thirds right here, this is going to be 2/3 of the way from 0 to pi. So this is my 2 pi over 3. And then we're just going to look at the lovely angle formed by that terminal side right there and the x-axis. So it's this angle that I'm wanting. So how far is it between 2 pi thirds and 3 pi thirds? Well, just subtract them. 3 subtract 2 is 1 pi third. So 1 pi over 3 is your reference angle right there. Okay, if you do convert it, you're going to get 60 degrees. This will turn into 120 degrees. So the distance between, or the difference of 120 and 180 is 60 degrees if you need to check that one. All right.